Hi, good afternoon. This lecture video is a continuation of our examples in differential calculus. Okay, I hope you were able to study and understand the two previous examples because in this lecture video, I'll be solving four more additional examples. Okay, sample problems 3, 4, 5, and 6. Okay, so problems 3 and 4 are about instantaneous rates of change. Okay, so problem 5 is about the calculation of errors in measurements through differentials. And the last sample problem in this video, problem 6, is about tangent and normal lines. Okay, so if you're ready, let us begin solving these problems. Okay, so this is problem 3. Excuse me, let us read the problem. Boyle's law states that when a gas is compressed at constant temperature, the product of its pressure and volume remains constant. I need to have a pointer. Okay. So the product of the pressure and the volume remains constant. If the pressure of the gas is 80, this is psi, pounds per square inch. When the volume is 40 cubic inches, find the rate of change of the pressure with respect to the volume when the volume is 20 cubic inches. Okay, so these are worded problems. Okay, so the important thing about worded problems is that you should be able to convert these verbal statements into mathematical expressions. Okay, so that is one of the important skills that you need to have in order to succeed in calculus. Okay, kinakailangan marunong tayong mag-convert ng worded statements into mathematical expressions. Okay, so let us solve this problem. Okay, first, we need to represent the quantities in terms of variables. Okay, so there is a law mentioned here, is Boyle's law. So if you're familiar with this in chemistry or in physics when you were in high school, so it's one of the laws of thermodynamics, Boyle's law. Okay. Now the quantities involved here are pressure and volume. Why? Because the temperature is constant. Okay, so in Boyle's law, the temperature does not change. So it's a constant quantity. So what are the variables? So when you say variables, these are the quantities that change, namely the pressure and the volume. So we should be able to represent these quantities in terms of variables. Okay, so for us to easily represent them, the letter, the beginning letter of the word will serve as the variable. So we will use P for pressure and V for volume. Ayan, para hindi na tayo mahirapan. Okay? So let P be the pressure and V be equal to the volume. Now, according to the problem, the pressure of the gas is 80 psi. So that is a given quantity. So we write P equal to, okay, so first, I forgot this. The product of the pressure and the volume remains constant. So let's take the product. P times V is equal to a certain constant K. So that is our first expression. We obtained that from this. No? Okay, so the product of the pressure and the volume remains constant. Okay, so what is the next quantity or expression that we can make? The pressure of the gas is 80 psi. So we can write that as P equal to 80 and the volume is 40 cubic inches. So we write it as V is equal to 40. So these are the given quantities. Now, what is asked in the problem? Find the rate of change of the pressure with respect to the volume. So when you say rate of change, alam naman natin yung rate of change, that corresponds mathematically to what? Mathematically, what does rate of change represent if it's instantaneous? It represents, yes, you're right. It represents the derivative. So this must be the derivative because it's the rate of change of what? The pressure. So that must be the derivative of the pressure with respect to the volume, and we write it as dP over dV. At what particular condition? So when the volume is 20 cubic inches, that is why we write when V is equal to 20. So this entire worded problem is now converted into these mathematical expressions. Now, after having written all of these mathematical expressions, we can now solve the problem. Okay? So, ang hinahanap dito, dP over dV when V is 20. So, therefore, that's the derivative of P with respect to V. But before we can differentiate P with respect to V, we need to first have an expression for finding P, or simply an expression for P in terms of V. Okay? So where do we get that P in terms of V? So we get that from here, no? From this equation. No? So PV is equal to K. So thus, P is equal to K divided by V. So that is our working equation. No? So what do we do with this working equation? We now get dP over dV. Okay, that is simply the derivative of this. But this expression can be written as K. So this is a constant K. And this is a variable in the denominator which we can write as V to the negative 1. Like this. Right? Kasi reciprocal. Kaya nagkaroon ng exponent na negative 1. Now, so we can now differentiate this. Okay? Remember, this is a constant and this is a variable. How do we differentiate P with respect to V? So this exponent becomes a multiplier here. So that will be negative K V to the, so you subtract 1 from the exponent here. So negative 1 minus 1 is negative 2. So we will get dP over dV is equal to negative K V to the negative 2. Okay, so this negative 1 here came from the exponent. And then after that, we subtract negative 1 from the exponent. So we get negative 1 minus 1 is negative 2. Okay, so after that, it's time to substitute the condition. Okay, so guys, this is one important reminder to you. Never ever substitute this in the working equation. No? You only substitute the condition right after differentiating. So, differentiate muna. Kuha muna yung derivative. Pag nakuha yung derivative, saka mo ilalagay or isa-substitute yung condition. Okay, so I can write this dP over dV as negative K over V squared. Now, ayan, negative of K over V squared. But sir, what is K? Remember, K is a constant. No? And that constant, remember, is equal to what? That constant is this K, which is equal to product of the pressure and the volume. But we have pressure and volume given to us. No? May bigay sa atin na pressure at saka volume. Kaya kinakailangan gamitin mo yun. Pag hindi mo sila ginamit, baka magtampo yan. Okay, so para makuha natin yung value ng K, we substitute the values of P and V here. So 80 times 40, of course, 8 times 4 is 32, dalawang 0. So 3,200. Now, tapos yung V, saan manggagaling? Dun sa given, ayun, when V is 20. So that will be negative of 3,200 divided by 20 squared. Now, so this is 400. 32 over 4 is 8. Oh, okay. So that will give us 32 over 400. Makakancel yung dalawang 0. So 32 over 4, that will give us 8. And we have a negative sign there. So the answer is negative 8. And what's the unit? So the unit of P, of course, is PSI, and the unit of volume is cubic inches. That's why the unit of our answer is in PSI per cubic inches. Now, you might ask, sir, what is that negative sign for? What is this for? So the negative sign here indicates that the quantity is decreasing. That means that lumiliit yung quantity at that particular instant. Kaya po siya ay negative. Okay? Yun lang po ang ibig sabihin ng negative sign. Okay? So that's it. So reminder ha, pag nagsosolve ng rate problem or instantaneous rate of change, kinakailangan kunin muna natin ang derivative bago tayo substitute the conditions. So substitute the conditions after differentiating. Okay? So we can now proceed to the next example, which is problem number 4. Still, this is about instantaneous rate of change. Now, let us have the problem. So we have here a spherical snowball. Okay. Snow. Kahit ang init-init ngayon. So, spherical snowball that is melting, natutunaw, ang bolang, gawa sa yelo in such a way that the surface area is decreasing. Lumiliit yung surface area natural. Habang natutunaw ang yelo, lumiliit ang kanyang surface area. Gaano daw kabilis lumiit yung surface area? Lumiliit siya at a rate of 1 square inch per meter. Okay? Now, how fast is the radius decreasing when r is equal to 3 inches? Okay? So, kagaya ng ginawa natin kanina, ang una natin gagawin, we need to first translate the worded problem into mathematical expressions. Diba? So, there are variables here. And the quantities that vary will be represented in terms of variables. Okay? So, ano mga quantity yung nagbabago dito? Una, surface area. Okay? So, if we let the surface area be equal to A, kasi area, no? And aside from that, what else is given? It decreases at a rate of 1 square inch per minute. So, there is another quantity that changes the radius. So, I represent the radius by R. Okay? Now, the area decreases at a rate of 1 square inch per minute. So, how do we represent this 1 square inch per minute? So, it's very obvious. This is a square inch, no? A unit of area. And this is minute. So, that is a unit of time. So, that is a unit of area per unit time. Okay? So, we can represent it as what? Okay? Can you guess? Yes, that's correct. That's your dA over dt. And since it is decreasing, it should be negative. Okay? So, we represent dA over dt as negative 1. Now, so this 1 square inch per minute is the rate at which the area decreases. No? So, the negative sign here indicates that it's a decreasing quantity. Now, ano ang hinahanap dito? So, how fast is the radius decreasing? So, when you say how fast, that is something measured with respect to time. Is the radius decreasing? So, that is the rate at which the radius changes. So, we write it as dr over dt. What is the condition required to get dr over dt? When r specifically is equal to 3. So, this is now the required quantity. Okay? So, we're able to convert this problem into mathematical expressions. Now, we need a working equation from which we will start our solution. What do you think will be our working equation here? Here we have dA over dt. But we need dr over dt. Saan ko kukunin ang dr over dt kung may given na dA over dt? Alam ko na. Alam natin kung ano yung surface area ng sphere, di ba? Can you recall in geometry, what is the formula for finding the surface area of a sphere? No, it's not pi r squared because that is the area of a circle. We're talking about the surface area of a sphere. So the formula is 4 pi r squared, the surface area of the sphere. Okay? So that's why it's in blue. No? That means it's an important formula. No? That you should have recalled or remembered. Kung hindi mo naalala, ayan, tandaan mo. Okay, so what do we do with this working equation here? Of course, we differentiate it with respect to what? R? No, because the problem involves changing with or rate of change with time. So, if we get the derivative, it should be derivative with respect to t. So, we differentiate both sides of this equation with respect to t. What is the derivative of a with respect to t? Of course, that's dA over dt. Okay? And what's the derivative of this with respect to t? So, 4 pi is just a constant multiplier. How about r squared? How do you get the derivative of r squared with respect to t? Of course, we use chain rule. No? So, the derivative of r squared is 2r. But, it's with respect to t. So we're not done yet. After 2r, no? Sabi ng chain rule, differentiate mo pa siya, no? dr over dt. Okay? So the derivative of this will be dA over dt, and this will be 4 pi multiplied by the derivative of r squared with respect to t, which is 2r multiplied by dr over dt. Okay? So 2 times r, yan. Ito na po yung ating derivative. Sir, bakit ka nga ulit nag-multiply ng dr over dt? Kasi nga po, kung wala yung dr over dt, dinifferentiate mo lang to with respect to r. Okay? But we are differentiating with respect to t. That is why, itong 4 pi, kinopya mo doon. Derivative ng r squared with respect to t is 2r dr over dt. Okay? Kasi nga po, with respect to t, not with respect to r. Okay? So remember, chain rule. No? Now, after that, we substitute. Di ba sabi ko kanina, after mong kumuha ng derivative, saka ka magsa-substitute. Ano yung dA over dt? Do we know this? Yes, that's negative 1. How about r? Do we know this? Yes, given. Ayun. So, na makukuha mo na ngayon yung hinahanap. Now, we plug in the values. This becomes negative 1. This becomes 3. Now, we are ready to solve for dr over dt. Okay? So, to get dr over dt, we just divide this negative 1 by this entire expression. Okay? So, we will get 2 times 4 is 8 times 3 is 24. So, that will give us negative 1 over 24 pi. Okay? What is the unit? The unit of r is in inches and the unit of time is in, sabi dito, minutes. So, that will be inches per minute. Okay? So again, why did we have a negative sign here? Because it is said that the quantity decreases. Ayan, no? So how fast is the radius decreasing? So it's only natural for us to get a negative answer. So of course, that is not very much important because we are after the magnitude here. So this is the magnitude at which the radius is decreasing at the instant when the radius is equal to 3. Okay? So, I hope you are able to understand this problem. And just like the previous example, the constant reminder is that you have to know the working equation. No, mostly these are important equations from your previous subjects like geometry. If it involves a geometric problem, and after that you get the derivative. After getting the derivative, you substitute the choices, or not the choices, the given quantities, and after that you solve for the required quantity. Okay, so that's it. Now let's proceed to the next example. Example number 5. This we will be solving a problem that involves the calculation of errors. Ano, yung mga error kapag nagme-measure tayo, pwede nating makompute gamit ang calculus. Okay, so this is the problem. The radius of the sphere is measured as 5 with a possible error of 0.02 inch. Now find the approximate error and the percentage error in the computed value of the volume. Okay, so just like what we did in the two previous problems, we first represent the quantities that change in terms of variables. Ano? So, alin dito yung mga variables na nagbabago? Yung radius, no? So, yung radius ay r, natural, no? Sir, paano natin i-represent yung error? Okay. So, this is a new concept that I want to introduce to you. In calculus, we represent errors in terms of differentials. No? So, if there is a measurement in the quantity x, no? Yung measurement mo, yun yung x. How about the error in the measurement of x? That is the differential of x dx. So in this case, if we measure the radius and let the radius be equal to r, how do we represent the error in the radius? Yes, that's the differential of the radius, which is dr. Okay? So, tatandaan po ha, in calculus, errors are represented as differentials, not derivatives rather. So, kung derivative yun, halimbawa, dy over dx. But pag differentials, it's only dx or dy alone. No? So, walang denominator. Okay, so now, let us represent the radius in terms of r. So, here, radius is r, and the error in the radius, in the measurement of the radius, we represent it as dr. Okay, so how much is r in the problem? So 5, the radius is 5, and the error in the measurement of the radius, which is stated in the problem, is 0.02 inch. So these errors are usually smaller, much smaller compared to the actual measurement. Natural, pag nag-measure ka, yung error mo ay mas maliit, no? Lagi kumpara dun sa na-measure. Alam mo, mas malaki pa yung error kumpara sa sinukat mo, di ba? So, maliit lang yung error. No? So, remember, the differential means napakaliit na quantity. Okay? So, this 0.02 is your dr. Okay? So, anong hinahanap ngayon? Approximate error in the computed volume. At saka percentage error sa computed volume. So, unahin natin yung error sa computed volume. So, error. Likdaan mo muna to. No? Error in the computed value of the volume. So, paano may represent yan? Remember, an error can be represented in terms of differentials. Error in what quantity? Volume. So, if the volume is V, the error in the volume is dV, right? Yes. So, how do we get the error in the volume and the percent error? We need to have a working equation. And the working equation, of course, is the volume of the sphere. Kanina ang ginamit natin, surface area. But this time, ang gagamitin natin ay volume. Kasi yun yung nabanggit. Ayan, no, volume. Ano ba ang volume ng sphere? 4/3 pi r cube. Okay, so ito po ang ating working equation. Now, anong susunod mong gagawin sa iyong working equation? So hot in here. Kahit bagong ligo ako, ang init. Okay. So, after obtaining or formulating your working equation, anong sunod mong gagawin? Hindi tayo kukuha ng derivative. Kukuha naman tayo ng differentials. Yes. Kunan mo ng differential magkabila. Ano ang differential ng V? Eh, di dV. Ano naman ang differential nito? Okay. So, 4/3 pi. Copy-paste lang to kasi constant siya. How about r cube? What is the differential of r cube? Ay di parang kukuha ka lang ng derivative. 3, bababa mo. And then r, magiging 3 minus 1 is 2. So, 3r squared. Okay. So, that's it. 4/3 pi times 3r squared. No? And then, the differential in r. No? Kasi, kung hindi mo ilalagay yung differential ng r na dr, eh di kumuha ka ng derivative with respect to r. No? But we are not getting the derivative with respect to r. No? So, pag kinuha mo yung dv over dr, dapat itong dr nasa denominator dito. So, kung yun yung hinahanap mo, that's 4/3 times 3 pi r squared. But, we're getting the differentials. Kaya dapat, after mong makuha yung 3 pi r squared mula sa r cube, lalagyan mo dito ng dr. Okay? So, may differential of r tayo dito. So, ngayon, after mong kunin ang differentials, isa-substitute mo na ngayon yung mga given. Do we know dv? Actually, hindi. Kasi yan po yung hinahanap natin. Do we know r? Yes, that's fine. How about dr, doctor? Yung dr, ito po yun, 0.02. Okay, so isubstitute lang natin dito. 5 squared is 25. Tapos yung dr times 0.02. So pag sinubstitute natin, ang makukuha natin ay ito, 4 times 25 is 100. Tapos 1, ito ay 0.02, so that's 1 over 50. 100 over 50, that's 2. So the answer will be 2 pi. Okay? So this is now the differential in volume, the differential volume, which represents the error in the measured volume. Yan na yung error mo ngayon, 2 pi or 6.20. Now, kasi 3.14 times 2, 6.28. Now, anong sunod natin gagawin? Kunin mo naman yung percent error sa measured volume. Paano ba kumukuha ng percent error? Ay di natural, error divided by the actual volume. No? Times 100. Okay? Kasi percentage. So, yung error na nakuha natin, ito yon, divided by the actual volume, which is this. Okay? Gagawin mo lang naman, para makompute mo yung volume, substitute mo lang yung radius na 5 dito. No? So, ito, sulat natin yung formula. The error in volume is the actual error divided by the actual volume. No? So, ano nga yung dV? That's 2 pi. At ano yung volume? Ito po, 4/3 pi r cubed. No? So, pag isinubstitute natin sa denominator yung r na 5, magka-cancel yung pi. At dito, simplify natin ito. Halimbawa, computein mo sa calcu, ang makukuha mong sagot ay 1.2%. So, ayan. Nakuha na po natin yung error sa measured volume at yung percentage error sa volume. So, in this example, again, let us have a recap. Ano yung mahalagang concept na dapat nating tandaan? Errors are represented in terms of differential. Okay, so remember, differentials are different from derivatives. Okay? So, pwede nyo naman i-pause, no? So, after one problem, you can pause before you proceed to the next problem. So that may time kayo para mag-sink in sa inyo yung example or yung discussion kung medyo mabilis para sa inyo. Okay? So, let us now proceed to the last problem for this lecture video. So, problem number 6 is about tangent and normal lines. Okay, so this is the problem. Find the equation of the tangent and the normal lines to the curve. So there is a given function here. Of course, this function has a graph. Now, at this point on the graph, ano daw ang equation ng tangent line at saka ng normal line? Okay? So if you remember our discussion in module 1, saan related yung tangent line, if you recall? Remember that the tangent line is related to what? Quantity in calculus. Yes, tama. The tangent line is related to the derivative. How are they related? The slope, that's correct. The slope of the tangent line is equal to what? Yes, the slope of the tangent line is equal to the first derivative of the function. So if that is so, malalaman natin yung slope nung hinahanap na line pag kinuha natin ang first derivative ng given function. Tama ba? Yes. So kung ito yung given function mo, kunan mo lang siya ng derivative. Okay, siguro naman marunong na kayo mag-differentiate nito, no? So kunan natin ang y prime ito. Ano ang y prime? So itong x cube magiging, that's right, 3x squared minus, what's the derivative of this term? 2 times 2, that will be 4. And then, yung exponent from 2, magiging 1 na lang. So, magiging 4x. Okay, and the derivative ng constant, 0 na. So, magiging 3x squared minus 4x. So, ayan, isulat natin. Ano naman ngayon? So, ibig sabihin pala, ang slope ng curve na ito ay nagbabago-bago. Sir, anong gagamit kong slope ng line? You have to evaluate this at the given point. No? Parang yung kanina, after natin mag-differentiate, saka mo i-apply yung conditions. Ano bang condition dito? Ito yun, no? Ang condition, ito yung point dun sa curve na pinag-uusapan natin. No? So, since dito ay may x, kinakailangan, i-substitute natin ang value ng x dun sa point na given sa problem. No? Kung saan ang value ng x ay 2. Okay? So, substitute mo lang, no? Ang wag y ha, kasi ang hinahanap natin ay value ng x, no? X kasi yung nandyan. So, ano ba ang value ng x doon sa given point? That's 2. So, you substitute 2 here. 3 times 2 squared minus 4 times 2. Anong sagot? Okay. So, this is 3 times 4 is 12 minus 8. 12 minus 8 is 4. So, ito na yung slope ng line na hinahanap natin. No? Again, anong nire-represent ng 4 na ito? That 4 is the slope of the tangent line that we are looking for. Oh, it's a positive slope. That means it's sloping upwards to the right. Just like. Okay? Now, Knowing the slope, can we now determine the equation of the tangent line? Yes, because we have a point. So if you remember, if you know a point and the slope, you can use the point slope form of the line. No? Because we know the we are given a certain point, which is 2, 4, and we're able to calculate the slope, which is 4. So, do you recall the point slope form of the line? That's y minus y1 is equal to m times x minus x1. So, ito po yun. Ano, kung saan yung x1 at yung y1, yun yung given point. So, substitute lang natin y minus y1, which is 4, is equal to m. No? Ito yung slope natin na nakuha. 4 times x minus x1. Ang x1 natin ay 2. So, substituting all the values, we have y minus 4 is equal to 4 times x minus 2 again. This y1 and x1 are the values of x and y given in the problem. No? And this 4 here is the slope of the tangent line that we are able to determine from the first derivative. Okay, so the last thing that we shall do is to simplify this expression. Madali lang naman 4 times x, 4x. 4 times negative 2, negative 8. So negative 8, ito magiging positive. Pag nilipat mo doon, negative 8 plus 4 is negative 4. So magiging 4x minus 4. So ito na po ngayon yung equation ng tangent line mo. Okay? Diba? Dali lang. Next, how about the normal line? So, kung natatandaan yung relationship ng tangent at saka normal line. Again, pag normal, anong ibig sabihin? Perpendicular. Now, so if two lines are perpendicular, what is the relationship of their slopes? They are, natatandaan pa ba? They are negative reciprocals of each other. So, yung hinahanap nating slope ng normal line, dapat negative reciprocal slope or negative reciprocal ng slope nito. No? So that must be negative 1/4. Yes. Bakit nga po? Again, the relationship between two perpendicular lines. Sir, bakit ba perpendicular? Kasi nga normal. Pag sinabi mo na normal, perpendicular yon. Synonym mo siya sa perpendicular. So this line is perpendicular to the tangent line. Now, and because it's perpendicular, again, its slope is the negative reciprocal of the other. Okay? So, yung normal line, dadaan din sa point na to. No? Pero ito yung slope na gagamitin mo. Hindi na yung 4. Ito na yung gagamitin mo. So, balik tayo sa point slope form. No? Papalitan lang natin yung m. Instead of using 4, we will use negative 1/4. And of course, we'll be using the same values of x and y. Bakit po? Kasi yung normal line, dumaan din sa point na to. So, actually, dun mag-intersect yung tangent line at saka normal line mo. Okay? So, using the point slope form, we have y minus y1 is equal to m, which is negative 1/4, times x minus x1. Now, so, again, the rest is algebra. Simplify mo lang po ito. No? So, negative 1/4 x. Tapos ito, negative, magiging positive. 2/4 is 1/2. So, negative 1/4 x plus 1/2. Okay? Tapos itong 4, maging positive, ilipat mo sa kabila. So, 4 plus 1/2 is 4.5 or 9/2. So, the equation of the normal line is this, negative 1/4 x plus 9/2. So, now there you have it, guys. We're able to solve for the equation of the tangent line and the equation of the normal line. Take note that the slopes, y equals mx plus b, itong m, they are negative reciprocals of each other. Why? Because the normal line is always perpendicular to the tangent. Okay? Pero hindi pa tayo tapos. No? Para mas ma-appreciate nyo yung last example na to, lagyan natin ang image. Ito yung actual graph ng given function, ng tangent line, at saka ng normal line. No? Para makita natin kung talagang sila ba ay perpendicular sa isa't isa. Ayan. So this curve, this blue curve, is the given function. No? Yun yung x cube. Okay? Chorbachenes. Samantalang yung red curve, kitang-kita naman natin ay yung red line ay tangent dun sa given curve, no, at this point. So itong point na to, yan ay 2, 4. 1, kasi tipo 0.5 yan eh. 0.5, 1, 1.52. Tapos yung y mo, ayun, 4. So ito yung 2, 4. No? Tapos dun sa point na yun, may tangent line. Ito siya. No? Yung red line. Na ito yung equation. Tapos, dun sa point na yun, may dadaan na isa pang line. Pero perpendicular naman. So ito siya. Ayan. Kita-kita natin 90 degrees yung intersection nila. So this line is this equation. No? Ito po yung equation ng blue line na ito. Okay. So ayan, no? Madali lang. Okay. So once again, if you need to pause the video so that the concepts and the discussion will sink in, then it's okay. No? If you want to write on your notebook as you listen to my discussion, you may do so. Okay? Hindi talaga. Maliligo na muna ulit ako. So hanggang dito na lang muna tayo. Ano? And see you later sa ating live online discussion. Okay? So I hope may natutunan kayo. Bye!